file plate print. Is it just a new method of screening? HD Flexo, not just a technology of screening, is a way to standardize and improve all processes in our company. The most important part of HD Flexo implementation is gathering knowledge about our current possibilities, weaknesses. It is first step, what we can improve with our current equipment, presses and so on. And next step, if it is not enough, what we need to change to achieve more. My presentation will be split to 3 parts: pre-press, so what we can do with our file, plate processing, what we can do with our plate, what is important and what we have to check, and last but not least, print. First idea was splitting to different segments of the market, but a lot of things is the same for all of them and I have just 45 minutes. About Flexo tools: how to increase Flexo output quality. First, plate making. Then, HD Flexo. Then, image retouching. Scalable and repeatable, Flexo tools dissolves the smoke around Flexo retouching. It's like having your best operator available on every workstation, every shift. Flexo tools. In order of importance is plate making, HD Flexo, pre-press. We will start from the end, from preparation graphic file. Of course, with possibilities of HD Flexo technology we can improve our printouts, but to be the best we need to remember about disadvantages of Flexo technology and avoid limitations. Viewer, Flexo plate preview. Highlights and breakouts. Halftones. Negative. Solids. Nothing, 0%. Viewer equals consistent QA and Desk Pack, Art Pro, and Pack Edge. In case a quality issue is detected, often an image needs to be retouched. Flexo Tools puts the same consistent QA tools in Photoshop and the smart tools to fix the issue at Flexo Clean and Flexo Fix. Flexo Tools, Flexo Clean. Views shows the problem. Scum dots and noisy breakouts. Risk of dirty printing. Flexo Clean automatically simplifies the breakouts, eliminating the risk. Works on any image. Flexo Tools, Flexo Fix advanced automatic image quality improvement. Ideal for photographic images, product shots. Restore color saturation. Restore contrast in the highlights, and more. Object screening microcell. Smooth vignettes to 0. And at 0, 78%. Also add very thin line, not printable, to stabilize first dots. It is mandatory that technical vignettes to 0 are ending at 0, 78% rather than running all the way down to 0%. This is because the RIP is mixing grade level 0% - 0, 38% minus 0, 78% below, which causes 0% holes at the vignette end. These holes are destroying the self-supporting structure of the HD Flexo screening dots and are leading to dirty printing at the end of vignettes. Balance dot sizes in the highlights. HD screening employs a novel solution in the highlights. It is not hybrid screening, but differentially modulated screening, where the dots remain on the regular grid as in standard AM circular, but in the highlight area they change size differently. There is a mixture of mostly smaller dots with a few larger dots. As a result, there are no isolated dots, so they all print in a predictable way. There are no gaps in the pattern. A smooth regular grid is the least visible to the eye. HD Flexo works across the whole tonal range. HD Flexo offers outstanding dazzling highlights, stable open midtones, even better than an offset, and via the new microcell technology a high solid ink density. Dots stay on regular grid, so pattern is not grainy. 7. Hash of tones equals resolution / screen frequency 2. Resolution, Y 4000p. The number of tones that can normally be reproduced with a halftone screen is equal to the number of spots in a halftone cell. To have a good quality we need at least 256 tonal steps, for every ink. To increase the number of tones you must increase the number of spots in the cell. This means either enlarging the cell, and decreasing screen frequency, or increasing the resolution of the image sitter. This relationship can be expressed as follows. Hash of tones equals resolution/screen frequency 2 plus 1 can skip. Resolution Y 4000p. So for resolution 2400 dpi screen frequency, 150 lpi hash of tones, 2400 202 equals 256, greater than OK, but it is limit. Of course we have intelligent dithering algorithm, but when dots are made of few pixels, they will be jagged. With some plate making processes, the jagged shape is transferred to plate. The jagged corners are weak spots on the dot. These jagged corners can collect ink. Mixture 7 and 8 px points to achieve percent we need. See the difference, here, small dots. 3.5% digital dot, screened at 212 lpi. Compare the difference between 4000 and 2400p output resolutions. 2400. 4000, but from other side. We can use worse materials, see below sample, image 150p and 300p. Taekwiniki Widrakuzi Abnazona Rosejail Chosha. HD Flexo Screens Installer. Very simple, short demo. Show how we can generate targets, plate making, processing steps, back exposure laser plate imaging. Main exposure. Washout and drying, thermal process. Post-exposure. Influence of the processing steps on the quality. CDI-focus, energy. Exposure. O optimum, 18 mW/cm2 and higher. O borderline, 18 mW/cm2, 16 mW/cm2. Not feasible, less than 16 mW/cm2. The best preparation of file with some problems during plate processing causes bad results during printing. Also temperature is very important, exposure needs to be cooled, temperature of lamps and table has influence. How to check plate making quality. Target has also AM screens, which is used as reference. Useful is also Hi-Fi target, the same for all plates. See reference pictures for DFH67. Sample 16px 20px 0, 5% reference field. The 0, 5% field looks similar to the reference plate, meaning a solid top. All dots the same size. If you touch this area with your fingertips, it should have the same height as the surrounding solid elements. Size CA 20 meters for 175, CA 25 for DFH. Print, 1 color test and inks Anilocks tapes press samples. 1C is printed with standard parameters of printing. Next, we can choose the best one and install libraries. Inks UV-labels, folding carton, flexible packaging and others. Recommendable plates, DuPont DFQ, DPN, DPI, DPR, Flintase, Asahi Def. Digital noise should be eliminated from images by using ESCO Artwork Flexo tools, clean below 0, 78%. Round Fagra dot shape should be used for substrates sensitive to modeling, for example paper label stock. Water-based ink stash. Corrugated preprint and post-print, folding carton and others. Recommendable plates. Corrugated post-print, DuPont DPN, DuPont DS2, Flint Art. Corrugated preprint, DuPont DPR, DuPont DS2, Flint Art, Flint Act. Folding carton, DuPont DPR, DuPont DPN, DuPont DFQ, Flint Act. Round Fagra dot shape is recommended. Ink solvent inks, flexible packaging and others recommendable plates. Smooth transition to zero use hard plate, for example DuPont EPR/DFQ, Flintase, Flintfab, McDermott Rave, Asahi DSH. High solids, use softer plate, for example DuPont DS2/DFS, Flint Act, McDermott DMAX, Asahi DSF. For hard plates use screens from either the Flexibles Low Volume, LV, or Flexibles Medium Volume, MV, section. Comment, Flint prepare new series for HD Flexo, see samples. Anti-locks, UV inks and water-based inks, Anti-locks LPI 5x job LPI, and for excellent highlight cell volume less than 5 cubic centimeters /m2, 3 bcm/in2. Solvent inks, Anti-locks LPI 6x job LPI, tapes. Use harder tapes to improve solids, use softer tapes to improve highlights. Use a tape that is as hard as possible for best combination of good solid ink, density and good highlight printing, and that still avoids bouncing. For combination of solids and screens. Hard plates should be mounted with medium hard tapes. Softer plates should be mounted with medium soft tapes. Plates containing only solids and line work, no screens, should always be mounted with hard tapes, for example for spot color or white printing. When you are facing bouncing on the press, this often can be reduced by softer tape, especially on wide web presses. Paper adhesive label stock requires softer tapes to prevent mottling. Never reuse tape for high-quality prints, although most printers do so. Sample, 5 different tapes for the same plate. Press, overimpression. ESCO artwork, HD Flexo, sample. 1% homogeneous gray printed with CMY. Very homogeneous printout despite CMY usage clearly shows the superiority of perfect highlight screening. Smooth and high contrast shadow without visible edges. High detail sharpness. Perfect highlight step wedges. 0, 5% in file 2% in print. 1% in file 3% in print. 2% in file 5% in print. 3% in file 9% in print. Total 10 gray values print with less than 10% with excellent tonal dynamics. Perfect contrast in highlights. No need to compensate CT. 0, 5% in CT prints with only 2% density. No need anymore to bump up CT, no loss of image contrast. Vignette to 0. Smooth vignette transition to 0. ESCO artwork, HD Flexo technical details. File percent. Print percent in cyan wedge. Circular. Perfect. Highlight. 8, 0%. 28%. 18%. 7, 0%. 26%. 17%. 6, 0%. 24%. 15%. 5, 0%. 23%. 14%. 4, 0%. 22%. 11%. 3, 0%. 9%. 2, 0%. 21%. 5%. 1, 0%. 19%. 3%. 0, 5%. 2%. Screen, perfect highlight TM and circular. Imager, CDI Spark 2530 high-res optics. Plate, DuPont DFQ, thermal plate. Press, Gallus RCS 330. Anti-locks, cyan, 420 liters/cm, depth 11 micrometers, volume 3, 1 cubic centimeter per square meter, 60 degrees. Magenta, 420 liters/cm, depth 11 micrometers, volume 3, 1 cubic centimeter per square meter, 60 degrees. Black, 320 liters/cm, depth 16 micrometers, volume 4, 7 cubic centimeters per square meter, 60 degrees. Yellow, 320 liters/cm, depth 16 micrometers, volume 4, 6 cubic centimeters per square meter, 60 degrees. Ink, UV ink, Flint. Substrate, pop white gloss, primer 60 micrometers, intercoat. ESCO artwork, HD Flexo. Smooth and high contrast shadow without visible edges even when black is running to 0. High detail sharpness with smooth transition to 0. High contrast in highlights and shadows. Black is used to increase shadow details but does not lead to sharp edges when running to 0, transition shadow highlights. Perfect highlight step wedges. 0, 5% in file, 2% in print. 1% in file, 3% in print. 2% in file, 5% in print. 3% in file, 9% in print. Total 10 gray values print with less than 10% with excellent tonal dynamics. Perfect contrast in highlights. No need to compensate CT. 0, 5% in CT prints with only 2% density. No need anymore to bump up CT, no loss of image contrast. Vignette to 0. Smooth vignette transition to 0. ESCO artwork, HD Flexo technical details. File percent. Print percent in cyan wedge. Circular. Perfect. Highlight. 8, 0%. 28%. 18%. 7, 0%. 26%. 17%. 6, 0%. 24%. 15%. 5, 0%. 23%. 14%. 4, 0%. 22%. 11%. 3, 0%. 9%. 2, 0%. 21%. 5%. 1, 0%. 19%. 3%. 0, 5%. 2%. Screen, perfect highlight TM and circular. Imager, CDI Spark 2530 high-res optics. Plate, DuPont DFQ, thermal plate. Press, Gallus RCS 330. Anti-locks, cyan, 420 liters/cm, depth 11 micrometers, volume 3, 1 cubic centimeter per square meter, 60 degrees. Magenta, 420 liters/cm, depth 11 micrometers, volume 3, 1 cubic centimeter per square meter, 60 degrees. Black, 320 liters/cm, depth 16 micrometers, volume 4, 7 cubic centimeters per square meter, 60 degrees. Yellow, 320 liters/cm, depth 16 micrometers, volume 4, 6 cubic centimeters per square meter, 60 degrees. Ink, UV ink, flint. Substrate, pop white gloss, primer 60 micrometers, intercoat,